Hi students, my name is Otin Joseph. Welcome once again to another lesson on grade 7 mathematics. Today we are going to explore the topic probability. What is probability? Probability simply means the study of events that may occur or may not occur. So we have a lot of things happening, a lot of events happening. We don't know whether it is going to occur or it will not occur. Even if it will occur, we don't know the degree of certainty at which the event may occur. So taking this into consideration and studying it in mathematics, we call it probability. So probability is simply the study of events which may occur or may not occur. In other terms, you can define probability as the numerical value that is used to represent the degree of certainty an event may occur. Okay, so if an event may occur in mathematics, we use a number, a certain number to represent. The size of the number tells the degree at which we are certain that the event will occur. Let's explore the types of probabilities. We have two main types of probabilities I'm going to talk about. But not only two, we have more types, but I'm interested in discussing these two main types of probability in this lesson. We have theoretical probability, and then we have experimental probability. What is theoretical probability? Theoretical probability is calculated as number of ways the event occurs divided by the total number of possible outcomes. Number of ways the event occurs divided by the total number of possible outcomes. Theoretical probability talks about natural events like a person is pregnant, a woman is pregnant. Okay, a woman is pregnant. We know that if someone is pregnant, the person either gives birth to a boy or a girl. A boy or a girl. So the number of ways the events will occur. The events we are talking about here is the either giving birth to boy or girl. That is the event we are talking about here. So if the person is going to give birth to a boy, the event is boy. If the person is going to give birth to a girl, the event is girl. We don't know whether the person is going to give birth to a boy or a girl. So the total number of outcomes, possible outcomes, is 2, boy or girl. So we have 2 total number of possible outcomes. If I want to predict that a pregnant woman is going to give birth to a boy, then the probability of boy is going to be boy over boy or girl. So it's going to be 1 over 2 because boy or girl, we add the 2 outcomes. So we get total possible outcomes of 2. And then the outcome that we are looking for is boy, so it's 1 over 2. If I also want to say that the person is going to give birth to a girl, then it is going to be probability of giving birth to a girl, and that is going to be girl over boy or girl. And that is going to take the same form as 1 over 2 because the outcome we are interested in is girl. And then the total possible outcome is boy or girl, that is 2. Okay, so that is also 1 over 2. This is called theoretical probability. This, we are not performing any experiment to predict some possible outcomes. It is happening. The person is pregnant, and it is happening naturally. Let's come to experimental probability. We talk of experimental probability when we are conducting an experiment and we want to predict the outcome of that experiment. Examples of experiments are like tossing a coin. And when you are tossing a coin, you are not aware or you never know whether you are going to get a tail or a head. So predicting whether a tail or a head will turn up after tossing the coin is an experimental type of probability. Tossing a die, you don't know whether you are going to get 1, 2, 6, or 5. So therefore, tossing a die is also an experimental probability. And the way to find an experimental probability is dividing the number of times the outcome you are interested in occurs by the total number of times the experiment is conducted. So if I toss a coin 3 times, that will be the total number of times the experiment is conducted. And let's say tossing the coin 3 times, and I'm interested in predicting that a head will turn up in all the 3 turn-ups. So that will be the number of times my head is going to turn up, the number of times the outcome is going to occur. Okay, so let's say if in all tossing of the coin, head is going to turn up 3 times, then I'm going to have 3/3. Okay, and that is my probability. Take note, probability is a fraction. Okay, probability is a fraction. We are going to talk of the laws of probability later on in the next lesson. The study of probability comes with a lot of terms you might not be familiar with. So let's go through some terms that you would come across as we journey through probability. The first term is experiment. I have already mentioned experiment in the previous explanations. What is an experiment? An experiment is any operation whose outcome cannot be predicted with certainty. If you are doing something and then you are not sure of the end result, you are not sure of what is going to happen at the end of what you are doing, then what you are doing is exactly referred to as an experiment. Example is tossing of a coin. You don't know whether you are going to get head or tail. Throwing a die, you don't know the number that will turn up after throwing the die. So all of these are experiments. Let's move on to the next thing. Trial. An experiment may be performed as many times as you wish. So a single performance of an experiment is called a trial. Let's say you are tossing a coin and you want to toss the coin 3, 4, 5 times. Any single tossing of the coin is called a trial. So if you are tossing it 5 times, then it means you are going to have 5 trials in that experiment. Putting all the trials together give you the experiment. So an experiment can have only one trial or many trials as you wish. The next term is random sampling. Random sampling. If you have a population of samples, let's say you have a group of balls of different colors but of the same sizes, then you have a population of samples. And you want to pick any sample, any of the balls, without being biased. Picking without being biased simply means you are not particular with the type of ball or the color of ball you want to pick. You are just picking without being conscious of the type or the color of the ball you are picking. So you pick it before you get to know the color of the ball you picked. Doing that is called random sampling. I want us to do random sampling, a short random sampling right now here. Let's do some random sampling here. I have 10 cubes, a population of 10 cubes, 3 of which are blue. These 3 are all blue cubes. I have 3 cubes being yellow colored. All the cubes have the same size. Then I have 3 cubes being red and then 1 cube being green, making a total of 10. I want to mix all the cubes together and do a random sample. I am going to pick a cube without looking at the population and being particular of the color of the cube. Okay, so I'm just looking straight into the camera and picking a cube without being aware of it. Shoe, I have red cube. I picked red cube without knowing that I would pick red cube. Therefore, what I just did here is random sampling. I can also pick another cube. Yeah, I picked blue cube. Random sampling. Let's do the last random sampling. This time around, I picked another red cube without being aware of the cube color of which I would pick. Okay, so picking something from a group of things without being aware of the type or the color of the particular thing you are picking is called random sampling. We say you are doing it without being biased. The next terminology is sample space. What is the sample space? The sample space is the set of all possible outcomes of an experiment. You are performing an experiment and you are aware of the possible result of the experiment. So you build a set and put in every expected result into that set, and that set becomes the sample space. For example, throwing a die. When you throw a die once, you are expected to get the numbers 1, 2, 3, 4, 5, and 6 turning out. Okay, so any one of these numbers can turn up after throwing the die. Therefore, I build a set and put all my possible outcomes, and this set becomes the sample space. Okay? Let's move on to the next terminology, event. An event is a collection of sample points with a common identity. Okay? So to get an event, you take your sample space. For example, this is the sample space for throwing a die once. Let's take an event of getting an even number. The event is also a set, okay? And it should contain points in the sample space that have common identity. So let's build an event for even numbers. So 2, 4, 6. This is an event from the sample space. I have numbers from 1 to 6, and I have 3 even numbers, 2, 4, 6. Building a set for the even numbers out of the sample space gives an event. So this is an event of even numbers. It is a subset of the sample space. I can also build an event of odd numbers. So 1, 3, 5 form a set, and this is an event of odd numbers. You can find these sets, all these sets in the sample space. All events are subsets of the sample space. Okay, you can go on and list more events, like events of prime numbers, events of multiples of 3, events of multiples of 2. More events can be listed from this sample space. Okay, so the event is a collection of sample points or a set of sample points with a common identity. Let's move on to the last terminology. The next terminology is equally likely events. Events which have equal chances of occurring are referred to as equally likely events. For example, if someone is pregnant, the person has the same chance of giving birth to a boy or a girl. Therefore, either a boy or a girl child may result. Both chances are equally likely to occur, so they are called equally likely events. Let's move on to the next terminology, which is mutually exclusive events. Mutually exclusive event. When you have any two events whose occurrence affects each other, then they are called mutually exclusive events. For example, light and darkness cannot occur together, okay? So if there will be light, then darkness cannot prevail, or darkness cannot show up itself. And if there is darkness to light cannot show up itself, the two of them cannot mix and occur together at the same time. Therefore, the occurrence of light and darkness, or day and night, is called mutually exclusive events. The next thing is independent events. If we have two events whose occurrence do not affect each other, then they are called independent events. For example, the sun and the rain can come together at the same time. And it can be raining whilst the wind will still be blowing in. So the wind and the rain can be occurring or taking place at the same time. The occurrence of the rain does not affect the occurrence of the wind. So the two events are independent. We are done with our introduction to probability in this lesson. We are going to get more deeper into it in the next lesson video. Take your time, stay safe, and watch the videos and explore to your very understanding. Thanks for watching. Bye-bye.